down its correct species. So our task is to build a machine learning model that can learn from her data to predict the species of a new flower, just from its measurements.
And this is what her data looks like to a computer. See? Each flower is a sample, which is just one row. And those 4 measurements, sepal length, sepal width, petal length, and petal width, those are our features. We're essentially translating the physical flower into a nice, neat table of numbers that an algorithm can actually understand.
Now check this out. When we visualize this data, something really cool happens. This is a pair plot, and each color on here represents a different species of iris. Just look at how they form these nice, distinct clusters. See, for instance, how the blue dots down here are totally separate from the green and red ones? This visual separation is a massive clue. It's telling us that a machine learning model should have a pretty good shot at learning the boundaries between these groups. This is a very good sign.
So seeing that clear pattern in the data is basically our green light. We've got our data, we have a clear goal, and it definitely looks solvable. So now it's time to actually build our digital botanist.
But hang on, there's a really critical question we have to ask ourselves first. If we use all of our flower data to teach the model, how can we be sure it actually learned the patterns and didn't just, memorize the answers? A model that just memorizes is useless in the real world. We need to know if it can handle a new flower it's never seen before. And the solution to this is actually pretty clever. We split our data. We take a big chunk of it, say 75%, and we call that our training set. This is the data the model gets to see and learn from. But we hold back the other 25%. We lock it away and call it the test set. This data is kept totally separate, and we use it at the very end, like a final exam, to get an honest, unbiased grade on how well our model performs.
This gives us a super simple, repeatable 4-step workflow. Step 1, split the data, just like we talked about. Step 2, choose a model. We're going to use a really intuitive one called K-nearest neighbors. I'll explain it in just a second. Step 3, we train